Welcome to day 15 of our low-level design course. Today we are diving into two very important design patterns that are foundational for structuring and enhancing the flexibility of complex systems. These patterns are the composite and decorator pattern. Both of these fall under the structural design patterns category, and they help simplify relationships between objects and allow for more scalable and maintainable systems. In our next few slides, we will explore the problems they solve, their structure, real-world applications, and code implementations. Let's get started. Here's an overview of the agenda for today's lesson. First, we will start by revisiting what structural design patterns are so that we are aligned on their purpose and importance. Then we will focus on each of the patterns individually, starting with the composite pattern. We will define the pattern, look at its components, walk through a UML diagram, explore real-world examples, and see some code. After that, we will move on to the decorator pattern following the same steps. We will then compare the two patterns to see when to use each one and wrap up with an activity and homework. Let's dive in. Before we jump into the specifics of the composite and decorator patterns, let's do a quick recap on structural design patterns. These patterns focus on how objects and classes are composed to form larger structures. The goal is to simplify the relationships between objects and to make systems more flexible and easier to scale. We have already seen patterns like the adapter and the bridge that help us decouple classes, making them more reusable and easier to modify. Today we will look at how the composite and decorator patterns enhance this flexibility by managing object relationships and responsibilities in a systematic way. The composite pattern solves a common problem in system design. How do we manage tree-like structures where we have both individual objects and groups of objects and treat them uniformly? For example, imagine a file system where you have both individual files and folders. A folder can contain files, but it can also contain other folders. How can we make sure we handle both files and folders in the same way without writing separate logic for each? That's where the composite pattern comes in. The composite pattern allows us to treat individual objects and compositions of objects in a uniform way. This is ideal when dealing with hierarchical structures or part-whole relationships like the aforementioned file system or a graphics editor. The key is that you can compose objects into tree structures that represent part-whole hierarchies. The advantage of this pattern is that it makes it easy to treat both simple and complex objects in the same way, reducing the complexity of our code and making it easier to maintain. The composite pattern has three primary components. Component. This is the common interface or abstract class that defines the operations. Both the leaf and composite will implement this interface. Leaf. This represents the individual objects that do not have any children. For example, in a file system, a file would be a leaf because it does not contain any other objects. Composite. This is a container that holds other components. It can contain both leaves objects and other composite objects, allowing us to build a tree structure. With these three components, we can create a hierarchical structure that makes working with both simple and composite objects seamless. Here's a UML diagram illustrating the structure of the composite pattern. Both the leaf and composite classes implement the component interface. The composite class has a collection of child components, which could be either other composites or leaves. This allows us to easily manage a tree structure where both types of objects can be treated the same way. Notice how the composite class can contain both types, facilitating recursive operations on the structure. Let's look at some real-world examples of the composite pattern. In a file system, files are leaf nodes, while folders are composite nodes that can contain other files or folders. This hierarchical structure allows us to interact with files and folders in the same way. In an organizational chart, individual employees are leaves, while managers or teams are composites that can contain more employees or other teams. In a GUI system, UI elements like buttons or text fields are leaves, while panels or windows are composites that can hold multiple UI elements. These real-world examples showcase how the composite pattern simplifies the management of complex tree-like structures. Let's now see some code for the composite pattern. In this example, we have a file system node base class. The file class is a leaf that represents individual files, while the folder class is a composite that can contain other file systems, whether they are files or folders. This allows us to treat files and folders uniformly, making it easy to display the file system structure. With this pattern, we can recursively perform operations like displaying the structure or calculating the size of the files. Now let's shift gears and talk about the decorator pattern. The decorator pattern solves the problem of how to add new behavior to objects dynamically without modifying their existing code. For example, imagine you have a car class and you want to add different features to the car, like a sunroof, leather seats, or advanced navigation. Instead of subclassing car for every combination of features, the decorator patterns allows us to add these features as decorators at runtime in a flexible way. The decorator pattern allows us to add new responsibilities to objects dynamically without altering their classes. It works by wrapping the original object in a decorator class that extends its functionality. This pattern adheres to the open-closed principle, which states that classes should be open for extension but closed for modification. Using decorators, we can add multiple functionalities to an object in a way that is both modular and flexible. The decorator pattern consists of three key components. Component. This is the common interface that both the original object and the decorator implement. Concrete component. This is the original object which we will decorate. Decorator. This is an abstract class or interface that wraps the concrete component and adds new functionality. Concrete decorator. This class extends the decorator and actually adds the additional behavior or functionality. By chaining multiple decorators, we can dynamically add different behaviors to the object. Here's the UML diagram for the decorator pattern. Notice that the concrete component represents the original object and the decorator class wraps it up. The concrete decorator extends the functionality of the component. This allows us to change decorators together to add multiple behaviors dynamically. Let's look at some real-world examples of the decorator pattern. Think about pizza ordering. A basic pizza is the original object, and toppings like cheese, olives, or mushrooms are decorators that add new functionality to the pizza. In a GUI system, consider a window that can have different features like a scroll bar or a border. Each of these features can be added dynamically using decorators. The input stream and buffered input stream classes in Java are an excellent example of this pattern. You can wrap an input stream in a buffered stream to add buffering functionality without altering the original stream. Here's a simple code example to illustrate the decorator pattern. In this case, we have a basic coffee class and we are dynamically adding features like milk or sugar using decorators. Each decorator wraps the original coffee object and adds functionality like adjusting the price or adding a description. This demonstrates how we can extend the functionality of an object without modifying its original code. Now let's compare the composite and decorator patterns. The composite pattern is used when you have a part-whole hierarchy. It allows you to treat individual objects and groups of objects uniformly. The decorator pattern is used when you need to add new behaviors to an object dynamically without modifying its class. The composite pattern is about structuring objects while the decorator pattern is about enhancing functionality. Both patterns are useful in different scenarios and understanding when to use each will make you a more efficient system designer. For today's hands-on activity, I would like you to implement a file system using the composite pattern. Create classes for files and folders and recursively display the structure of the file system. This will help you understand how to use this pattern in a hierarchical structure. As an extension, try building a coffee order system using the decorator pattern where you can dynamically add features to the coffee like milk, sugar, or flavoring. For homework, your task is to build a GUI widget system using the composite pattern. Represent elements like buttons, panels, and windows in a way that allows for easy composition. For the decorator pattern, implement a text editor where you can apply different text styles like bold, italic, and underline using decorators. To summarize today's lesson, the composite pattern allows us to simplify complex tree-like structures by treating both individual objects and groups of objects uniformly. The decorator pattern enables us to dynamically add new behaviors to an object without modifying its original code, making it flexible and scalable. Both patterns are important tools in your design toolkit, and knowing when and how to use them will allow you to create more flexible and maintainable systems. Thank you for your attention.